Hey guys, today we're going to look at physical and chemical properties of matter. So not only are we going to define what each is, we are also going to give examples. We're going to be doing a very in-depth lab during class in order to solidify this information, so don't think that this is going to be the end of it. The first thing we're going to talk about are physical characteristics. Physical characteristics of a substance are measurable characteristics that may be changed without changing the chemical makeup of the substance. So in real people words, what this means is that we have a characteristic that we can adjust, change, or alter without changing what that substance is completely. So for example, if you are making something in wood class, you can cut a piece of wood smaller, you can sand it to make it smooth, and you can stain it to change its color. All three of those changes are physical changes because they are changing just the physical characteristics. It is still a piece of wood on a molecular level, so that in itself is staying the same, but the physical characteristics are the things that are changing. So here's a list of a ton of examples of physical characteristics. The area of a substance, the boiling point of a substance. If you have ever added salt to water before you boil it to make spaghetti or macaroni and cheese, that is changing the boiling point of that water because you are now adding a second substance to it. Color, density, ductility is the flexibility or bendability of something. The electric charge, length, luster is how shiny it is. Mass, melting point, pressure, reflectivity is how well it reflects light, and then volume. Just write a few of these down. These are all examples of physical characteristics. Chemical characteristics are characteristics of a substance that indicate its ability to undergo a chemical change. If we have a chemical characteristic, or if we have a chemical change, that substance is no longer molecularly the same substance. So H2O changing into hydrogens and oxygens, that is a chemical change because we are breaking bonds and creating a new substance. So chemical characteristics is a much shorter list. First we have reactivity. How well does it react, or how much does it react to its neighboring substances or particles? When we talk about the periodic table, we're going to talk about how to tell reactivity of an element based on the location of that element. Heat of combustion is at what temperature does that item or substance actually start combusting. Toxicity is its ability to damage cells. So on a lot of things you'll see toxic if swallowed. That means that it has a chemical reaction with the cells in your body. Flammability is the ability to catch fire. And then the preferred type of bond would be if it's an ionic bond or a covalent bond, and which bond it is more likely to choose. Again, we're going to talk about that when we talk about the periodic table of the elements. So the two that people tend to get confused, heat of combustion and flammability. This is just the ability to ignite. Can it catch on fire? Heat of combustion is the temperature when it ignites on its own. So if you have a high temperature and a high pressure, certain gases will actually automatically combust into flame. So that's the difference between the two. Ability to ignite versus the temperature that it ignites at. I'm going to add the word at. Okay, so we have 4 indicators of a chemical change, and in our lab, these are the 4 things that we're going to be looking for to determine if a chemical change has in fact happened. If you do not see one of these 4 indicators, that means that it was only a physical change. So the first one is precipitate, and precipitate is a fancy word for a solid settling out. So this only happens if you mix 2 liquids and a solid is formed. It doesn't happen if you mix a solid and a liquid and there's still a solid there. So this is a solid settles out. And again, you will see an example of that during class. Creation of gas. This can be 2 things. Most people normally think of just bubbles. If bubbles occur when you mix 2 substances, and that's not just air bubbles being mixed in, but if you mix 2 substances and you get like this foam starting to create, that's a creation of a gas. Second one is smoke. If you see smoke, then it has been a chemical change also. Now the last 2 are very specific because I have to add a word in front of them in order for them to be a true chemical change. So the word is unexpected, and that works for both of these. We need an unexpected color change. That means if I mix red and blue and I get purple, that's an expected color change. That's something that I expect to happen. But if I mix red and blue and I get clear, that is unexpected. That means that is now a chemical reaction. And an unexpected temperature change. If I put an ice cube in a glass of hot tea, I expect it to cool down. But if I put two room temperature substances in a beaker together, it should not heat up or it should not become colder. If it does one of those two things, that would be considered a chemical change. So again, physical changes just the physical characteristics of the substance. The molecular breakdown is still the same for that substance. Chemical changes the molecular breakdown of the substance. Those are the two differences. Physical stays the same stuff, just changes what it looks like. Chemical now has new chemicals or substances in that mixture. We have changed the chemical makeup. And in order for a chemical change to happen, one or more of these four things have to be present. So in class, we're going to do like a 2 or 3 day long lab practicing identifying the different types of changes. We're going to be burning things, mixing things. You're going to be taking note of what's occurring and telling me if it was a chemical or physical change, and then telling me why. So I'll see you in class tomorrow so we can start practicing and get into the lab.